Apple eats AI for breakfast. That sounds like a bold claim, maybe even a little controversial. For the past few years, the AI conversation has been dominated by a few big names. NVIDIA's massive GPUs, OpenAI building bigger models, Anthropic building bigger models, Microsoft pouring billions into data centers, Google pouring billions into data centers. The future of AI is being built in the cloud, on giant power-hungry server farms. Many people wrote Apple off. They weren't building the biggest models. They weren't building the most powerful server chips. They were just making pretty laptops, phones. While everyone looked up at the clouds, they missed the ground. Apple was running a different race, not training the largest models. Solving inference, AI that runs on your device, answering your questions, editing your photos, helping you work. AI as a real tool for everyday people and businesses. By solving inference, Apple might be redefining the race. Critics called lack of cloud infra a weakness, called device focus a distraction. That misses Apple's strategy. They didn't try to beat NVIDIA at their game. They changed the game, focused on efficiency, integration, putting AI directly on the device without constant cloud connections. To understand why Apple's approach is so different, we first have to talk about a bottleneck. It's a problem that has plagued traditional computers for years, but most people don't see it. The problem isn't the speed of the chips themselves, it's the traffic between them. In a conventional PC, even a very powerful one with a top-of-the-line NVIDIA GPU, the main processor, the CPU, and the graphics processor, the GPU, are separate components. They are like two different buildings on opposite sides of a city. And critically, they each have their own separate pools of memory, their own private desks where they keep their data. Now, when you ask an AI model a question, the data has to move. The CPU might prepare the data, but the GPU does the heavy lifting. This means the data has to be packaged up, put on a digital bus, and physically shuttled to the GPU's memory. Once the GPU is done, the result often has to be sent back. This back-and-forth movement creates latency. It uses energy. It creates a hard ceiling on performance. Imagine two brilliant teams in separate offices across town. One prepares documents, the other analyzes them. But the only way to share files is a single courier van crawling through city traffic. Workers spend time just waiting for the next batch. That van is the memory bus in a traditional computer. It's a fundamental architectural limitation. For years, the industry's solution was to build faster vans and wider roads, more powerful GPUs and faster buses. But the core problem remained: the data was always in the wrong place. Every exchange requires copying across physical distance. It consumes power, generates heat, and slows inference when speed matters most. Apple asked a simple, powerful question: what if we just got rid of the traffic jam entirely? Apple's answer to the memory traffic jam is the core genius of the M-series chip. It's an idea called Unified Memory Architecture, UMA. Instead of giving the CPU and GPU their own separate memory pools, Apple put them at the same massive desk. The CPU, the GPU, the neural engine, all share a single high-speed pool of memory. There is no CPU memory. There is no GPU memory. There is just memory. Every part of the chip can access it instantly. No more shuttling files around. With unified memory, there's no need to copy huge chunks back and forth. The CPU simply tells the GPU, the data is right there on our shared desk. This slashes latency, slashes energy waste, removes performance ceilings. The courier van is gone. Everyone is in the same room. That's why a Mac can do impossible-seeming tasks for its size and power use. One part starts a task, another picks it up, a third finishes it, with no data shuffling penalties. More of the chip's power goes to work, not waste. It handles massive amounts of data with surprising speed, a game changer for AI. Large models need huge memory. Traditional VRAM limits complicate life. UMA lets a Mac dedicate a big single chunk, up to 192 gigabytes on an M Series Ultra, enough to run tasks that used to require a specialized workstation. Most people understand CPUs and GPUs. A CPU is a flexible generalist. A GPU is a huge crowd doing many simple tasks at once. But Apple adds a third piece, the neural engine, the NPU. Think of it as a specialized surgeon for matrix math, the core of AI inference. Inference is millions or billions of multiplications and additions over and over. A CPU can do it, slowly. A GPU is faster, but still not the specialist. The neural engine is built to do this with extreme speed and tiny power. The M4 neural engine can perform 38 trillion operations per second. It powers on-device features like photo recognition and real-time transcription without burning your battery. This dedicated hardware is Apple's secret weapon for fast, practical on-device AI. A Mac Studio, a quiet desktop, can run a 70 billion parameter language model locally. That's the same size class used by many enterprise AI services. A couple of years ago, this sounded like science fiction. Is it as fast as a top cloud instance with multiple high-end NVIDIA GPUs? No. But 8 to 12 tokens per second is very usable, fast enough to read along. And it happens offline with a fraction of the power. Consider a production line camera checking every item for defects in real time. The M4 Pro can process over 90 frames per second on object detection, plenty for many high-speed lines. You can run it from a compact Mac Mini, not a loud, hot server rack. Retail analytics on-site. Medical imaging with data staying local. Edge AI becomes practical. Here's the overlooked part of AI. Power cost. A single NVIDIA H100 can exceed 700 watts. A rack full can rival a small neighborhood's draw. Even Jensen Huang says AI's future is tied to energy costs. A Mac Studio might pull around 200 watts at peak, often much less. Less than many toasters or coffee makers. If you run inference non-stop, the yearly electricity savings are dramatic. A cloud GPU might be faster per task, but can use 10 times the energy. Scale across desktops and edge nodes, and the business case gets compelling. Lower power means less heat, smaller, quieter machines. Building private GPU clusters is costly. Renting adds up. Apple offers a third path. Buy once, sip power. For small businesses, developers, and enterprises at the edge, the economics are hard to ignore. This can shift budgets from renting compute to owning outcomes. And it all fits neatly on a desk. Beyond cost, Apple's on-device AI has a huge advantage: privacy. Cloud AI sends your queries, context, and documents to someone else's servers. In healthcare, finance, and law, that's a governance problem. Many leaders have raised concerns about data misuse and leaks. Run a 70 billion parameter model locally, and your data never leaves your machine. Analyze sensitive contracts, internal reports, or code. With confidence, it stays in-house. This turns AI from a service you rent into a tool you own. It's tempting to frame this as Apple versus NVIDIA. But that's not quite right. They're running different races. NVIDIA, led by Jensen Huang, dominates AI training, the cloud's engine room. Models from OpenAI and Anthropic train there. Apple focuses on inference, running those models efficiently in the real world. NVIDIA builds giant ovens to bake the AI cake. Apple perfects the appliance to enjoy a slice at home. Apple's goal isn't to help Sam Altman or Satya Nadella train bigger models. It's to put powerful, efficient private AI on every desk, for creatives, developers, and knowledge workers. The industry says serious AI lives in the cloud. Rent GPUs by the hour. Apple shows inference can be local, cheaper and more private. The market is bifurcating: cloud for training and max throughput, device for everyday, efficient inference. Apple leads that on-device track by a wide margin. And the ecosystem reflects it. NVIDIA for training, Apple for on-device, OpenAI GPT, Google Gemini, Sundar Pichai, xAI Grok, Elon Musk, Microsoft and DeepThink Microsoft, Anthropic and AGI ambitions, plus countless labs pushing forward. Apple's M-series offers a blueprint for AI's future. It's a call to think differently. Developers should build features that run locally, optimized for the neural engine and unified memory. Businesses should reevaluate AI strategy, many held back by cloud cost and privacy risk. Run pilots. Move suitable workloads from cloud to edge, to desktops, retail, factory floors. Regulators should encourage privacy-preserving on-device architectures. In tech, smart design often beats brute force. Moving data is expensive in time, energy, and risk. Minimize it, win more. Efficiency isn't just eco, it's a competitive advantage. Yeah. So where does this leave us? For years we were told AI lives far away, rented by the hour. Apple offered a compelling alternative. Immense intelligence, right here on the desk, in a quiet box that draws less power than a toaster. Local, private, economically accessible. This is not the end of the data center. The future is hybrid, cloud and edge, each doing what it does best. But a creator, a small business, a student, running world-class AI locally? That's revolutionary. It democratizes access and puts control back in your hands. Remember unified memory. Remember the neural engine. The biggest disruptions change the rules, not just the size. Apple eats AI for breakfast by rethinking the meal. Smart design, focused on the user, wins in the real world.